Okay, so for questions on slanted slope, there's one thing you need to know. The normal force is always perpendicular to the surface. So because it's on this slanted surface, the normal force is going to be this way. It's not going to be vertically upward, but it's going to be perpendicular to the surface. And yeah, so you're going to have to convert a lot of components, but it's not going to be like a simple thing. So I'll try to go through it a little. Yeah. Okay, so firstly, free body diagrams for this is I'm gonna name this one box 2, and then this one box 1. Okay, so firstly, there's a component of gravity which is going straight down, and that's going to be mg, and then there's going to be, because box 2 is falling, that means this box will be accelerating this way, so there's a tension that goes parallel, so tension, and then there's the normal force, which is perpendicular to the surface, and then there's friction, which will be this way. Yeah, so F friction. 7 kilograms. Okay, 7 kilograms means it's going to be 70 newtons. And now we need to convert everything into things that are parallel. That's how I'll note it. So like F parallel. So like going this way or this way, and then F perpendicular. So instead of having X and Y, that's what we're going to do. So the real big problem is you need to convert mg into this vector and this vector. And that really comes down to how to find this angle or this angle. So we know that this angle right here is, we know that this angle right here is 37 degrees. So we know that this one right here is going to be 63 degrees. How does that help us? Fuck. Oh yeah, if this one is 63, then this one is also 63. So this one is 37. So if we erase, so if we erase, so this theta right here, this one right here, is going to be 37 degrees. So you can test it out, but or you can try to figure it out on your own, but it is 37 degrees. So now it's not so bad. The parallel, the component of gravity that's parallel, which is this one right here, that one is going to be 70 sine 37 degrees, because this 37 is that 37. Yeah, so 70 sine 37 equals G parallel, and then G perpendicular equals 70 cosine 37. Okay, and then, yeah, so now it's just basic. So I'm just going to draw the free body diagram for box 2. We have mg, and we know it's 12 grams, so it's equal to 120 newtons if we use 10 meters per second squared. And then for the upward, you only have tension. So the acceleration, because when you have two things that are tied by a rope, the one and only assumption you can make about that system is that their accelerations are going to be the same. Their accelerations have to be the same. So its acceleration in the y direction is going to be, I'm going to assume it's going to be falling, or it's going to pull that box up one upward, and then the box 2 is going to go down. So its acceleration in the y direction is going to be the forces in the y direction divided by the mass, and we know that the forces in the y direction is going to be, if we make positive as t, then we get t minus 120 over 12 kilograms. And that's the speed that's the acceleration of box 2. And then so we're going to get a negative number because we know it's going to be accelerating downward. So actually, I'm going to switch this. This is going to be positive, this one's going to be negative. So 120 minus t over 12. And then this one we have to find the acceleration parallel to the surface. So you get all the forces parallel over m. So this is like the stuff I'm talking about right here is about mass, or is about box 2 or box 1. So the forces acting on it parallel to the surface is going to be T minus force of friction. And we know what the kinetic, so let me just substitute. Is force of friction is always mu, so coefficient of friction, which is 0.25 in this case, times the normal force. And the normal force is anything that makes it stop accelerating in the specific direction. And because we know that there is no acceleration downward or upward, like there's no combined acceleration that like upward or perpendicular, that because of that we know that the force normal is going to be equal to the force times gravity. So that means it's going to be force. So sorry, this thing right here is this. So we know it's 70 cosine 37. All right, that was long. Oh, so force normal equals g this. So 70 cosine 37. Yep, and then yeah, that's it. And then that's going to be the force parallel, and you divide by the mass, which we know is 7. Yeah, so those two things are the same, and now we have to just solve with algebra. So 120 minus 12 over t over 12 equals t minus, and I'm just going to put all of that in my calculator because it's a big mess. So okay, and then so 840 minus 7t equals 12t minus 12 times 12t minus 167.7 yeah, and plus 167 on both sides, so you get 1007 equals, and you add 7t to both sides, so you get 19t. So finally you get t equals 53, and it's going to be in newtons because tension is a force. Okay, and then it just tells us to find the acceleration. So we can plug into either one, but because this one is simpler, I'll just plug into that. 120 minus 53 divided by 12 equals 5.58. Yeah, so your acceleration is 5.58.